Okay, so let's look at exercise 9.2 as a recap over what we learned yesterday. So if I have this equation for the circle and I want to find out what is the center and the radius, okay, what do you think we should do first? Or what will you do after yesterday? Sorry? Put it back into standard form. Okay, you can do your completely a square, but yesterday we were looking at expanding that equation, right? Okay, so from now onwards, I will actually continue to do it in this manner, alright, rather than expecting you to actually memorize. Do you like to memorize instead? Okay, so you just stick to this method. Okay, completing the square, I'll leave it to you to actually do it if you're sure at it. Okay, I don't want to spend another 1 more hour recapping of completing the square and that. Okay, so in this case, then after that, we arrange the terms. Okay, then after that, we will want to find out what is the center, right? So how do we find the x-coordinate of the center? How to find? The axis, how do we find? The center, the x-coordinate of the center. The center would have the coordinates AD, right? Yeah. So we have this one achieving from the standard equation. So we are given that the given equation for the circle is this. How do we find out what is the x-coordinate? Shift. Compare. Can you compare? What do you need to compare? What do you need to compare between these two equations?
The coefficient.
You want to find A. What is the best thing to compare?
Coefficient.
Coefficient of
X.
this, what would it be? Which coefficient? I want to find A. So which one should I compare? 1 with which one? I have x squared, there's nothing for me to compare, right? Y squared, nothing for me to compare. Then I want to find A value.
Have you always been using my
Sorry? Minus 2A. And 2, do you know why? We are trying to compare, I want to find A. A is over here. I compare the terms with the x one, right? The variable x. Okay, so A will be equals to -1. Then after that, comparing the coefficient of y, we will get -2B equals to -10, so B is equals to 5. And then finally, okay, the constant term will be equals to 1. Okay, and therefore R squared 1 plus 25, 26. So the radius of the circle will be 5. And then the center is at -1,5. Okay? So we got an idea? Hannah? Alright, could we look at try 7? Okay. Try 7, the circle passes through A and B. Okay, and then after that part 1, we want to find out what is the equation of the perpendicular bisector of AB. What do I need to find first to find out the perpendicular bisector? Midpoint. finding the midpoint, and then after we find the gradient of AB. And therefore we find that also the gradient of perpendicular bisector will be equal to 2. Okay? Then after that we will be able to find out what is the equation of the perpendicular bisector. Could I erase the first question? Erase?
Yes.
Yeah? So the equation of the perpendicular bisector will be y equals to 2x plus 7. Okay? Any questions for part 1? It's just your last year's content. Okay? More importantly, let's look at part 2. Okay, we want to find out what is the center of the circle. Okay, given that the center actually lies on the equation 5x plus y equals to 0. Okay, how do you think we can go about doing this? Right? If so far we only know what are the points on the circle, these 2 points on the circle might not actually be on the diameter or on the same diameter itself. Okay? Then after that, we only have in part 1 the equation of the perpendicular bisector. How do you know that simultaneous will give you the center C?
So, the perpendicular bisector will
Okay, very good. Okay, so the perpendicular bisector of a circle. Okay, so we have a circle, then after that we have the tangent, right? Okay, the perpendicular bisector is not tangent. Okay, we have a circle and then we are given 2 points A, B. Okay, I do not know where these 2 points are. Right? So they will actually form a chord. Okay? Might be diameter, that one we're not certain. Okay, but definitely it will be able to form a chord. Alright? And then after that, we found for this chord, okay, what is the equation of the perpendicular bisector? Okay, in E-maths, when we look at circle properties, we have learned that the perpendicular bisector of the chord, right, will actually have to pass through the center. Property that we have learned in E-maths, and it will be frequently used when we actually do our coordinate geometry of circles. Okay, so please make sure that you recall that. Alright, so therefore, okay, knowing this equation of the perpendicular bisector already, which is y equals 2x plus 7, and then after that, knowing that there's an equation of a line, there's a line that passes through the center itself. Okay, so then we can solve simultaneously for us to find out what is the coordinates of the center. coordinates of the center C will be a negative 1, 5. Questions up to here? Alright, then after in part 3, we want to find the equation of the circle in general form. This is the standard form, by the way. Okay, so regardless of whether you want standard form or general form, okay, we know that general form is just an expanded version of the standard form. Okay, we will still need to know what is the radius. So at this point, we only know what is the center. How could we find out what is the radius?
It's A or B.
Use what? A or B. Okay, so we make use of the coordinates of A or B to find out what is the length of the segment, okay, from C to B or C to A. Alright, so that will help us to find out what is the length of the radius. Any questions up here? Okay, next we look at try 8. Okay, try 8 we only want to find out what's the coordinates of the point of intersection of the line and also with the circle. Okay, I think this one is manageable. How to do? How to find the point of intersection?
Find X and F.
Huh?
Coordinate of point intersection will
Just do simultaneous, right? Could I leave you to do it now? Okay, find out what is the point of intersection. I'll give you about 5 minutes.
Sorry.
Oh, this one's part 3, right?
Where did I write off? Equation of circle.
after you get the center, the A and B, right, you must take the negative B, right?
For what?
Center.
Uh-huh.
Must take negative, lah.
For what?
So like you compare the coefficient, right? After you get A and B, right, you need to
No, A and B are the centers already. Yeah, when if you do by the standard form manner. Only if you memorize the general form, then you need to consider you are able to get 4, 2, right? There is only one coordinate, okay? Because down here, if you plus or minus 0, it's still 0. Okay, there's no positive or negative 0. Alright, so therefore, there's only one point of intersection in this case. Okay. I hope also that when you do your simultaneous equation, you are manipulating, or rather doing the substitution by manipulating the linear equation rather than the quadratic equation. Okay, so I don't want you to actually manipulate this and then make x or y the subject, right? Making this the subject will be easier. Okay. So in this case, right, we find that it's actually a special case whereby having a circle and then after that having a line such that it touches at only one point. Okay, this point has a special name. It's called point of contact. Okay, I rarely use such terms, but just to introduce it to you, just in case you come across it in any of the books that you're reading.
Oh, I found your price. So it's a new one.
Okay. Now let's move on to try 9. In try 9, we are given this equation of a line such that it is actually a tangent to the circle with the center 3, -6. And this line is tangential to the circle at the point P. Okay, so part 1, we want to find out what is the coordinates of the point P. Okay, let's maybe just draw a diagram to illustrate this entire question. Okay, so we are looking at a circle, and then there is a center 3, -6. Okay, then at this particular point P, we have this line that satisfies this equation. Okay, and this point over here is P. We do not have the equation of the circle, right? So what could we do to find out the coordinates of P? We only have the equation of this line. Okay. Radius? No, what radius do you want?
Find the equation
Of what?
You do something to bicycle.
I want to say differentiation.
Okay, so no, we cannot differentiate in this case.
So that's
Okay.
tangent.
So just now we earlier on covered that when there is a tangent, okay, tangent and a circle, okay, what kind of properties do you recall of it?
90 degrees.
90 degrees, tangent perpendicular to radius, right? Remember this property? That the tangents of a circle is always perpendicular to the radius, right or not? Okay, so the radius, okay, yes, it is a length, okay, but in this case, let's look at radius as a line. Okay, this line is 90 degrees to this tangent. Okay, could we actually find out what is the equation of this radius? Okay, we could find out the equation of the radius, that line itself. Okay, and then after that, you realize that this radius itself, once we have the equation, we could actually find out the coordinates of P. Because this will be the intersection between the radius line as well as the tangent line. Okay, so that will be the approach that we will take to solve this question. Okay, so with the tangent line, okay, we will first be able to find out what is the gradient. So the gradient of the tangent is 4/3. That makes the gradient of the perpendicular line. We are not looking at the perpendicular bisector because this line is kind of goes off forever. Okay, so we're not looking at any bisectors in this case. Okay, so gradient of its perpendicular. Okay, maybe not perpendicular. There's a name for it, right? What's the name?
Normal.
Okay, of its normal.
结果因为
Sorry,
我
what?
真的一个多。
Yeah, I forgot. Okay, so -3/4. Okay, so gradient of its normal is -3/4. So therefore, the equation of normal will be y minus -6 equals to -3/4 x minus 3. Okay, so the equation of the normal would be y equals to -3/4 x minus 15/4. Okay, then after that, now we can find out what is the coordinates of P. So let me just rewrite it out here. So therefore, P will be at having the coordinates negative 1, negative 3. Okay? Wait, did I substitute? Oh. Therefore, 3/4 minus 18. Substitute back into right? Or negative 1.
But then
Does it still give me?
but negative 2 is
Negative 3 correct.
minus. Oh yeah.
Okay, any questions? Okay, then in part 2, the question wants you to find the equation of the circle. So if the question asks for the equation of a circle, they did not specify whether they want general form or standard form. Okay, either will be fine. Alright, there's no need for you to actually, if you're really bad at expanding, okay, then after that, you just leave it as the standard form. That will be good enough. Alright, so in this case, we have already found out the coordinates of P and we have the center at 3, negative 6 as well. We need the radius, so we just have to find out what is the length of the radius by considering the point P as well as the center. Okay. It's just a number that is not too small, not too big. Okay, and it's a perfect square. No, I will not go through your test later on.
I got 1 question. D3 period.
No, I will not do revision. Why no? What do you want to ask? Differentiate. Okay, just make sure that you simplify your answers. There's just some pointers I can tell you, that's all. Yes.
No binomial, right?
Yes.
They will ask like, is term what over term what?
Sorry,
Term something over something, the ratio is, for example, what is the
The coefficient you
coefficient?
Yeah, okay, and sorry.